Welcome to The Soft Learning, where we explore the latest advancements in engineering and technology. Do you see a 3D printer in operation? That's really interesting. Today, we're delving into the world of additive manufacturing and how process simulation is revolutionizing this cutting-edge field. We are diving deep into process simulation for additive manufacturing. So, what exactly is process simulation, and why is it important in the realm of 3D printing? Process simulation involves using computer software to model and simulate the entire additive manufacturing process, from the initial design stage to the final part of production. This includes simulating material deposition, heat distribution, cooling rates, and residual stresses. By simulating the manufacturing process before physically printing the part, engineers can optimize various parameters to achieve the desired outcome, such as minimizing distortion, reducing defects, and improving mechanical properties. So, how does process simulation work in additive manufacturing? Let's break it down into key steps. Pre-processing. Engineers start by importing the 3D CAD model of the part into simulation software. They define material properties, process parameters, and build orientation. Simulation setup. Next, the software generates a finite element mesh and applies boundary conditions to simulate the thermal and mechanical behavior of the part during printing. Simulation run. The simulation is run, and engineers analyze results such as temperature distribution, cooling rates, and residual stresses to identify potential issues and areas for improvement. Post-processing. Finally, engineers interpret the simulation data and make adjustments to optimize the printing process, such as adjusting scan paths, optimizing support structures, or modifying material parameters. By iteratively simulating and optimizing the additive manufacturing process, engineers can reduce trial and error, minimize material waste, and ensure the production of high-quality parts with greater efficiency. Examples of process simulation software for additive manufacturing include ANSYS Additive Suite, Autodesk NetFab, and Materialize Magics. These tools empower engineers to simulate various AM processes, including powder bed fusion, directed energy deposition, and material extrusion. In conclusion, process simulation is a game changer for additive manufacturing, enabling engineers to predict and optimize the entire printing process with precision and accuracy. If you found this video informative, don't forget to like, share, and subscribe to The Soft Learning for more content on engineering and technology.